Now, let's go back to what we saw in the previous classes. What is economic complexity and how to connect it with the policy. So let me first go briefly on what is economic complexity, just to repeat it 2 or 3 times during this series of lectures. We saw that economic complexity starts from data on what countries are doing. In this case, for example, what countries are exporting, where each row is a country, each column is a product, and each orange dot represents if the country is successfully exporting that product. The general idea of economic complexity is to use network science on these metrics to extract indices, to extract information that is policy relevant. What we do with this, we build basically 2 forms of indices. On one side, we build indices connected to the ranking of countries and products. So the idea being that there is a natural order of rows and columns such that with advanced countries on top and least developed countries on the bottom, complex products on the right, and simple products on the left. And in this natural order, the position of countries is informative. And we saw in the classes that this natural order is given by a complexity algorithm, like the fitness complexity algorithm that we saw with the Andrea Tacchella class. We also saw that there are ways of computing if products or activities are related between them. So in this case, for example, it's a matrix of all the activities that countries do. So for example, here in blue there are export markets, in yellow there are scientific activities, in red there are technologies, and how they are connected. So which countries that are able to do agricultural patents often have scientific expertise in molecular biology or biochemistry. Reasonable things, right? And this is so these are the 2 broad families of indices that we build. On one side, measure of complexity of a country or complexity required to do an activity, for example, to export a product. On the other side, relatedness between activities. Now, how to use this for policy, right? Economic complexity has been used extensively for policy, so we don't have to guess. There have been several usage of economic complexity for policy, and in particular, my team, when I used to work at the European Commission, did several used the economic complexity technique for several forecasting exercise. Let's give some example. Here we use we have in a plot on the x-axis the fitness of the country, so that would be how high it is in the natural order, in the centrality of the network, of the expert network, and on the y-axis the GDP per capita of the country. And what we observe is that countries that have higher fitness than what you would expect given their GDP per capita will grow. And we are not making a causal claim here, we are just making a forecasting claim. And there have been studies by the group led by Andrea Tacchella, checking how well we can forecast, how well we can understand the GDP per capita of countries in the future, and in 2021 they came out with a paper showing that this is actually the best way of making GDP forecast today, comparing it with, for example, IMF techniques and so on. So here, with these two axes, on the x-axis, what you do, and on the y-axis, how much you do, will show that there is a good what you do is actually a good predictor of how much you do. A nice point is that you can see here that these are very effective techniques because they are not just for predicting where the country GDP will be, but they are giving a full distribution. So the idea here is how the forecast is done here. Well, you're looking at how the country moves in this plot, and what you say is that if a country is here, it will go in the same direction that other countries that were here before went. Okay, very similar to how we do weather forecasting, for example. And but the nice thing is that we don't have to just say the average growth rate, but we can actually build an interval. We can say, okay, there is the expected growth in real term of GDP for Italy, for example, will be around 0%, but it can be between minus 0.25 and plus 0.31. Okay, this is annualized in 5 years. In a 5 years time span. This was this is an aggregate measure, an aggregate forecast. So forecasting a GDP. Again, we are not implying that there is a causal implication here. There is we're not saying that since you are fit, then you will grow, or that if you become more fit, you will grow more. It's just saying that since you are fit, our prediction is that you will grow more than another country, but we don't know what would have happened if that country would not. But we can do also more refined forecasts, not just forecasting how much you will produce, what will be your GDP, but we can forecast which product you're going to make. We can try to forecast that the country, which product is doing today, and this product will do in the next years, right? And this is immediately policy relevant, because countries want to know these kind of things, want to know what is going to happen. Also because even if we don't tell, we cannot tell with these techniques how to affect this probability. We will not tell which is the best policy. Very often they don't care. Imagine that you are in a pension fund for a country, right? You are a policymaker in a pension fund. You just want to know the GDP forecast because you want to know how much you will have to save for the future pensions. It's not that you can affect the growth of the country. You just have to manage your fund. And very often this is the case, right? Very often even policymakers have a very limited control on which variables they can affect and which variables they cannot affect. And maybe they want to understand how to change things in their own respect, but we live in a complex system, and a lot of things are not under control by each policymaker. So each policymaker will affect a small part, but his small part is also affected by a lot of other things that the policymaker cannot affect, but he still want to predict, both in his country and in other country. So maybe, for example, an Italian policymaker could be interested in knowing if France will start exporting solar panel in 5 years. Not because they can affect it, but because it's it will affect their maybe a market is relevant for Italian firm, right? So this is this kind of forecasting are very useful at the very refined way. But we can do more, because here these are in the example that we see until now, we saw examples that are in one layer. So we forecasted, for example, products, right? Which products a country is going to export. But there is no reason to look at one dimension at a time. You can look at multi-dimensional analysis in different dimensions at the same time. For example, here you can see that we see at the same time which countries does some scientific activities, some technological activities, and some production activities. This is what we saw before, right? And this is very informative, because we can see, for example, not only that countries that are good in math often are good in physics, but we can see that, for example, that countries that are doing some technologies more than randomly in 5 years will do some export. And now we are not giving a causal interpretation of this result. We're not saying that if you want to do that export, you have to do those technologies. But we are able to forecast which export you will do by looking at which technologies you are doing today. Right? And this is very informative. And also because we can look at, for example, at a specific product. This, for example, is desktop computers. And you can look at the technologies that are relevant for desktop computers. And you see that different technologies, so in this case, the product is very disaggregated because it's a desktop computer, but it's not a sector, it's a specific product. And the technologies are more aggregated. So here there are 21 categories. But we can look at also at technologies that are more disaggregated. We can look at products that are more aggregated, and we can choose the kind of information that we want to give. And the advantage is that, for example, we can make forecast related to geographical divisions for which we don't have data. So, for example, we don't know which region are doing exports, so we cannot do forecasting of product exports starting by products because we don't know the data. But we know which region are doing technologies because patents are easy to localize at regional level because we know the address of the inventors, and therefore we can make specific maps. We can see for this product, for example, direction finding compasses. It's an electronic product, so imagine GPS and these kind of things. And we can make a map of which regions are better suited, are more likely to export this product in the next 5 years. Which regions that are not exporting it today are more likely to export it in the next 5 years. And not only, we don't have to limit ourselves to technology, science, and production. So, for example, here we are looking at the impact of technologies on specific jobs, right? And that it could be very useful because, for example, we want to forecast which region will be more affected by technological shocks, right? Which regions will be more affected depending on which jobs are more relevant in the region. And so, for example, we can look at the regions that were adopting more specific technologies, which jobs they gained, which jobs they lost, which jobs they gained the wage, which jobs they gained the lost wage maybe, but they got more position, and that is informative for policymakers, right? So this is the general idea on how we can inform a policy through economic complexity. There are several studies. We can look at, we'll not go into the detail into it, but for example, we can look at sector fitness. We can make a measure of fitness specific to some sectors, right? So in machinery, in electronic equipment, we can compare different years for the same country, right? This is Italy. And we can check and understand which sectors will grow, which sectors will decline, and this is informative for policymakers. Now, in the next part, we will look at, in particular, prediction analysis for sustainability.